Just install OpenFOAM. Now let's run your first CFD simulation. In this video, I'll guide you through setting up and solving a simple case in OpenFOAM from scratch. Alright, so let's start by running your first CFD simulations. In this video, I will be only taking a very simple case and telling you only the basic commands to run the simulation and how to do the post processing. I will not be explaining in detail very much in this video because this is the purpose of this video is to only show you like how you can run your basic simulation. Okay, basic OpenFOAM, how to run OpenFOAM simulation, like you can take it like this. Okay, I'll not be explaining thoroughly. I'll be giving you some brief introduction about the things, but the more descriptive part I will do it in the next video, and that video will be longer. Okay, like 1 hour or 1.5 hours. In this, I'll be explaining each and every point, but in a of any case which I will decide to show you. Okay, so let's start by how to run a CFD simulation in OpenFOAM. Okay, so first what we will do, we will take a case from a OpenFOAM tutorials. Okay, so to open OpenFOAM tutorial, we have to type this command cd foam tutorials. Okay, so we are inside the tutorial directory of OpenFOAM. You can see there are many tutorials. Today I am taking the case of incompressible one, so I will go in the cd incompressible. So we are inside that. Now you can see there are many cases, so I will be going inside icoFoam. Okay, so cd icoFoam. Okay, so here you can see that there are many things: simple foam, piso foam, pimple foam, icoFoam. These are the solvers. These are the different solvers which OpenFOAM used for solving the CFD problems, and these solvers are being involved in different cases. Okay, so what are these solvers? What are they implementing? What is the concept behind them? Okay, so I will be explaining all these things. Don't worry, in the coming videos I'll be explaining each and every solver of OpenFOAM. Okay, don't worry about that, and we will be applying it and we'll be performing the whole simulation. Don't worry, because I'll open cd icoFoam by typing cd icoFoam. Okay, now we are here. All right, so I will be going inside cavity, so cd cavity. Okay, all right, one more cavity is there, so I will be going inside that cavity. Okay, now this is our case. Okay, so one thing you must remember, that please do not run the OpenFOAM simulation when you are in the OpenFOAM tutorial. Okay, because this is the this is the, keep it like as an sample. Okay, because if you run here, okay, everything will be solved here only. Okay, every file and everything, if you make any changes in the block, in the meshing and everything, it will be done here only. So afterwards you cannot copy the fresh case. Okay, are you understanding what I am trying to tell you? Okay, so keep this as a fresh case. You just copy, which we'll be doing, copy it into another directory and then run your OpenFOAM case there. Okay, run your simulation there. Okay, please do not run the any simulation, any solver here inside the tutorial folder of OpenFOAM. Okay, you just copy the case in some other directory, in some other folder, and run the things there. Okay, please do not run the solver, the OpenFOAM simulation here. Okay, so we will be first we will copy this. So I go back and I want to copy this cavity one. Okay, I want to copy this cavity folder, means all the contents, like you copy something copy some folder in the in Windows. So we'll be copying this directory from here also. So to copy and paste, we'll be doing that thing in simultaneously by giving some commands that I'll tell you right now. To copy, you have to type this cp -r cavity. Okay, So cp means copy, minus r means the, if you wanted to copy any directory, the full directory means the folder. So if you wanted to copy the full folder, you always have to give minus r command after cv. Okay, and then after cavity you have to give a space and write the path where you wanted to paste your directory, your copy directory which you have copied. Okay, so I'll be giving the path like home and Muthu. Okay, so this is the path where I'm going to copy it. Okay, so I'll press enter. Oh, sorry. So now, yeah, now it has been copied there. Okay, so if I'll press cd, now I'm in my home directory. Okay, I'm in the path, I'm in this path. Okay, if I'll type pwd, you will get this path only. Okay, so I'm in this path. I'll write pwd, so it has shown me that this is the currently this is the path where I am. Okay, I'll press ls. You can see that cavity directory has been copied here. Okay, in my home directory. So you can just go inside cd cavity, press ls. Okay, all the things are there. Okay, so now let me give you some brief introduction about the contents which is there inside any OpenFOAM directory. Okay, OpenFOAM case directory. Okay, so right now our case directory is cavity. So you can see there are three main folders. One is zero, another is constant, and the third one is system. These three folders are mandatory to make an OpenFOAM case. If these three folders are not there, your OpenFOAM simulation will not run. Okay, so please make sure these three folders are there. Okay, we will be making one whole case ourselves only. Okay, we will be not be copying any case from anywhere. We will make the whole case by our own only. Okay, that we'll be doing afterwards. Okay, but right now let's get the brief introduction. What does the zero directory means? In the zero directory, all the boundary conditions are there. Okay, if you have learned cfd, you must be knowing what is the boundary conditions. Okay, so like the what like for example, if you wanted to specify the velocity at inlet and outlet, so you have to make the file for inside the zero folder. We will go inside the zero directory, and when you will press ls, you can find that velocity and pressure are there. So these are defining the velocity for the boundary conditions and pressure for the boundary conditions. Okay, so these both are there, and if you want to specify anything else like any type of force or anything you want to specify, you have to specify here only for the boundary condition. Okay, so this is the zero directory, meaning of the zero directory. What is the meaning of the constant? Constant means like any of the properties you wanted to define. Like you want to define the, like if you are taking the condition of flowing of water in a rectangular box. Okay, so what is the viscosity of the water, what is the density of the water? So basically the properties, like if you wanted to define the gravity, like acceleration due to gravity, the value of the g, that too you have to define in this constant directory. Okay, so the properties of the fluid of anything you are just trying to simulate in OpenFOAM, that you have to define in constant directory. Okay, now comes the system one. So in the system directory, these are there to control the simulation, basically. Okay, to control the simulation in the system. Okay, like how, like when you can see blockMesh dict, so everything regarding the mesh is there inside blockMesh dict. Like if you want to define mesh, like if you want to make a rectangular mesh, okay, so everything, every points, like how it is, let me show you. I will not be explaining the terms inside the blockmesh dict directory, blockmesh dict file. Okay, because these are some terms that I'm not going to tell you in this video. I will be telling you in another video, because that will take time. Okay, only I'll be explaining you brief introduction. What is this? Okay, okay. So yeah, because I won't make this video much longer. Okay, this is for simple running the case. Okay, yeah. So like block mesh dict, like in the control dict, you can go, you can see that this file control dict file is there for okay, I just missed this. Yeah, so control dict file is there for which solver you are using to run the simulation, how much time from where you are starting, like your start time, your end time, what is your time step, everything must be there in this control dict file. Okay, you can see that start time is 0. Application means the solver which you are using. We are using icoFoam solver. Start time means 0 time is 0, and time is 0.5, and delta t the time step is 0.005. Okay, so these things have to be mentioned in control dict, and many other things are there that I will be explaining afterwards. Okay, yeah. So this is the thing. Now you come to you can see that one decompose part dictate there, f schemes, fv schemes, and fv solution are there. uh we'll discuss it afterwards. Okay, we'll discuss it afterwards because it will be taking much more time to explain. Okay, so we'll be discussing these three afterwards. Right now let's be there till blockMesh dict and control it. So basically in the system directly, to control the simulation, everything has to be there inside the system directory. Okay, so let me explain once again. Boundary condition will be there in the 0 directory. All the properties of the fluid will be there inside the constant directory, and everything which will require to control the simulation, okay, that will be there inside the system directory. Okay, now how to make the mesh. Okay, now the point comes how to make the mesh. You have to only type this command, block mesh. Okay, now the question will come like how you are defining the points, like how you are defining the length of the things and everything. So that we have defined as I have shown you in the block mesh dict, okay, which is there inside the system directory. So that all the things have been defined in the of the mesh have been defined inside the block mesh dict file. Okay, so how to make the mesh? The command, the simple command is block mesh. Block mesh. And one more thing, this command uh, you have to be outside of 0, outside of constant, and outside of system. Okay, you cannot be inside any of these three folders. If you are inside any of these three folders, this block mesh command will not run, nor the solver will run. Okay, anything will not, any command regarding the running of the simulation on OpenFOAM will not run. Okay, you have to be outside these three folders: 0, constant, and system. So we are outside, so we will just type this block mesh and press enter. So now you can see that it has end. So our mesh has been prepared. Okay, there was no error. If error was there, something it has shown. Okay, no error was there, so our mesh has been generated successfully. If you want to check, you can just give one command, check mesh. Okay, so it will tell you everything, and in the end it will if the mesh is good, mesh is okay, it will write mesh okay in the end. Okay, so it will tell you each and everything that I will discuss it in the coming videos. Okay, so now our mesh is prepared. Okay, so now we can run our solver. It is a very basic tutorial which I am running. So because in other simulations you have to run many things before running the solver, many things you have to run between block mesh and the solver. Okay, so this is a very big case, so nothing is required, only you have to run block mesh, and then you can run directly, you can run the solver. Okay, so to run the solver, we are using icoFoam, so I am just typing icoFoam and press enter. Okay, so our solver has run and our simulation has been completed because the end time was 0.5 as I have shown you in the control dict file. So it has ended 0.5. Okay, if you press ls, you can see that our time directories have been written, so our result have been prepared. Okay, now we have to do the post processing with the help of the ParaView. So how you can do it? For doing the post processing, you have to do one thing. Okay, this one, touch foam.foam. Okay, you can give any name, but the file extension should be .foam. Okay, I have made it touch foam.foam. You can take it like touch 0.foam. Touch is the command to make an empty file. Okay, you can make any empty file with the help of the touch command, not with .foam extension. You can make any empty file with any extension if you want to make Python file. Okay, so you can write touch space 0.py, so it will make an empty Python file. Okay, nothing will be there, it will only make empty file. So we will require an empty .foam file to open this the results of this in the ParaView. Okay, so that's why I'm just doing this thing. Okay, so touch foam dot foam and press enter. You can give any name, like you can give it like touch one dot foam. So the file name of dot foam will be one dot foam. Okay, that's fine. I'm just giving it like this. Okay, now for your simplification, I'll just give cft.form. Okay, so yeah, to press ls, you can see that cft.form has been written. Now to open this in the ParaView, what you have to do, type paraview.exe, type cft.form. Okay, press enter. So it will directly open the results in the ParaView. You can see that it has opened the ParaView, but results are not coming. It will come. You can see one apply is coming. So click here on apply. Yeah, you can see that results are here. So first I will show you the uh, the the mesh. Okay, so we will go in the wireframe and I'll select solid color. Okay, so yeah, you can see that this is our prepared mesh. Okay, this is our prepared mesh which has been prepared. Okay, you can make it more coarse, more finer by changing the things inside the blockMesh script file. Okay, that is you have to do, but everything regarding the mesh will be there inside the blockMesh script file. Okay, so that is there. Now I will show you the you have to go to surface. I will explain about this, about the ParaView, each and every command of the ParaView. Don't worry about that. I'm just showing you the results which you have done. Okay, so if you click u means velocity. So this is our velocity contour which we have got. So right now the results it is showing at the time of 0.1. You can just move to another second, 0.2, 0.3, 0.4, 0.5, because the end time was 0.5. So you can see the velocity contour is 0.5. Not much change has been there. Okay, don't worry, that doesn't mean that no change is being there. Changes are there, but okay, that's fine. Okay, in the same way you can just see the pressure contours also. So it is like 0.1, 0.2, 0.3, 0.4, 0.5. Okay, if you want to see streamlines, you can just go and click on this stream tracer and press apply. Yep, here you can see that streamlines, you can see streamlines are there. So it is showing that the how the fluid is flowing inside the cavity. Okay, let me, yeah, I've changed the background, so I think it will be more visible to you. Yes, okay, so yeah, so like this you can just see your result. Okay, so this is the thing which I wanted to introduce. This is the very simple simulation which we have run for all the beginners, for all the new who are new here, running the first simulation in the OpenFOAM. Like this you can run the simulation. Many things has to be done. This was the very simple case. We will be running more complex case in the coming times, so don't worry about that, and you will be learning more and more about the OpenFOAM simulation. Okay, congratulations, you have just run your first CFD simulation in OpenFOAM. If this tutorial helped you, hit like and subscribe for more OpenFOAM videos. Have questions? Comment below and I'll be happy to help.